Hi, my name is Hannah Whirling, and I chose to do a project on the awesome horseshoe crab. My project's about what they like to live in and where you can find them. First off, they are not true crabs, actually. A true crab will have antennae, mandibles, and they have 5 pairs of legs, but a horseshoe crab do not have the antennae or mandibles. They have 7 pairs of legs. And because of this, they're more closely related to spiders and scorpions than the common blue crab. And the difference between a male and a female is the second pair of legs on a male will look like boxing gloves that they use to hold onto the female when they're mating. And the female, all her legs look the same. And what's really cool about these animals is that they have a copper-based blood. It's a blue color. And they use this blood that whenever they're cut, it reacts to any bacteria when they're in the water so that it clots really fast. And in 1950, a scientist named Frederick Bang, he discovered an enzyme called limulus amoebocyte lysate that when it ever hits the bacteria, it will react. So today they're using this enzyme to test drugs and medical tools to see if it's contaminated before they use it for medical purposes. So for my question, when I was at the Dauphin Island Sea Lab, the Discovery Hall, I noticed that the crabs were just moving around and they were very active, and I was wondering why. I was thinking that they just did not like the feeling of the bottom of their tank and they just were not very happy. So I decided to state my hypothesis as if the horseshoe crabs are given the choice between a sand or shell bottom, then they will spend more time in the sand because they are usually found burrowed in the sand. So my project was 7 days. The first day I would measure the tank, and it was a 90 centimeters by 182 centimeter tank, and I measured it by 10% quadrants, and I filled up the 20% on each side with sand and shells and let it sit overnight so that they could get used to what was in there and they would know which side they prefer. The next day I would go in the morning and in the afternoon and at night and sit there for 10 minutes just watching them and see what they would do. And I would do this every 2 days. So for the next 2 days, I'd move it a little bit closer in to 40%, and then the next 2 days, I'd do it up to 50%. And so for the 20%, they didn't seem to really like that. They spent a lot of time in the sand, and one of them spent a little bit of time in the shells, like he wasn't sure what that was. And they spent a lot of time in the bottom of the tank, the neutral zone, because they're just moving back and forth from the sides of the tank. And for the 40%, they seemed to know that, hey, there's sand here, so they spent more time in the sand, less time in the neutral, probably because they couldn't really fit there because they were a little big. And then one of the crabs spent a little time in the shells. And the 50%, they spent a lot of time in the sand. And the horseshoe crab number 1, he finally went into the shells a little bit, but not for long. And so, in conclusion, my hypothesis was supported. They do enjoy the sand to burrow in. And they use that to hide from predators and also to sneak up on other animals because they'll go down and have their tail sticking up because they have a light receptor on the end of their tail to tell if they're completely under the sand or not. And they'll sneak up on animals in front of them to eat them. And so, in conclusion, you will find a horseshoe crab in the sand. You may find them in like oyster reefs, probably not. And the purpose of this is to know where to find them so that we could collect their blood to use them for the medical purposes of the experiment. Yeah. And so I'd like to thank Al, my awesome roommate, for getting up really early in the morning with me to go and watch horseshoe crabs for 10 minutes for a whole week. and for Caitlin and Cameron for doing that in the afternoon, and for teacher that did not teach our class, but she was teaching others. Her name is Joanne, and she let me use her tank and horseshoe crabs, and my mentor Greg, who helped me get the bricks to keep the shells and the sand on the side. Because at the beginning of the experiment, they kept on moving the sand and the shells around, so I couldn't really tell what they liked the most. So I had to try to figure out how to put a barrier in there. So, are there any questions? Probably, because she asked, does the size of the horseshoe crab make a difference of what side of the tank they were on? And I would say maybe, because at the 40%, the bricks were a little close. So, like, if they couldn't spend much time in the middle, because they're a little big, and they couldn't. So, yes. They do when the female is laying her eggs. She will go up to the shore with the male on top of her, and she will lay the eggs, and he'll fertilize them. And that is also a big part for birds and other crabs that will eat the eggs of the horseshoe crab. So, any other questions? Oh yeah, sorry. The two horseshoe crabs in the tank were males. Okay. Thank you.